Now our motto determine V naught with the help of Thevenin's equivalent, Thevenin's theorem. So how can we determine? First off, we have considered that is X and that is Y terminal. Okay, our motto determine V naught. So first of all, this is behave as a load resistance. So if you draw Thevenin's equivalent corresponding to XY terminal, then this 6 kilo ohm behave as a load resistance. That's why it is first of all remove it and determine RTH and VTH corresponding to XY terminal. So first of all, if you focus on RTH, then all independent source reduced to be 0. If voltage source available, then it is short circuit, and current source it's behave as a open circuit. If this one is short circuit, that is 6 kilo ohm, simply short, and that is 12. Here open circuit, and that is 4 kilo ohm, and here 8 kilo ohm, and clear, that is 4 kilo ohm, and here this one is 6 kilo ohm. Clear or not? And we are focused on that is X, and here Y, that is RTH. Clear? This is open and this is short. This one and this one are parallel. Combination of this one with series, and both are series. So combination of this one, these two, we got 6 into 12 divided by 18. 6 divided by 3. 6 divided by 18 means 3, 4. Yeah. Combination of these two, we got 4 kilo ohm. We got 4 kilo ohm. 4 and 4, that is 8, and 8 and 12 are parallel. So RTH is, that is 4 and 4, that is 8 and 12 are parallel. So we got 20, that is 4.8 volt. Okay, so RTH is 4.8 volt. Now next target is VTH. So how can we determine VTH? If you redraw the circuit, that is 6 kilo ohm, and here plus minus 6 volt, and that is 12 kilo ohm, here 4 milliampere, and that is 4 kilo ohm, and here 8 kilo ohm, and that is plus minus VTH, and this one is 4 kilo ohm. Okay, sorry, this is clear or not? First of all, make it. After that, you know that if you apply here loop current I1, our motto determine VTH means follow this path, or follow this path, or follow this path. Clear? Now if we consider that is loop current I1, here loop current I2, and here loop current I3. Okay, now here branch current I1 minus I2, and here I1, here I3, here I3. Clear? Now this loop current is I2, so I2 minus I3, here I2 minus I3. Okay, here I2. Now apply KVL in this loop. Apply KVL in this loop. Our motto determine, if you determine I3 and I2, then apply KVL in this loop, then we got VTH. So we are focused on I3 and I2. Okay, so first of all determine I1. Minus 2 plus minus 6 plus 6 I1 plus 12 I1 minus I2. This will equal to 0. Okay, 12 and 12, 6, that is 18 I1 minus 12 I2, this will be equal to 6, or you can say that divided by 6, then we got 3 I1 minus 2 I2, this will be equal to 1, equation number 1. That is equation number 1. Clear? Now apply KVL in this loop. Plus 2 minus plus 12 I1 minus I2, direction of I2 direction here, it means that is I2 plus minus. So minus 4 I2. Okay, better to write here 12 I1 minus I2 minus 4 I2 minus to plus. Follow this path, super loop. Okay, because of unknown voltage here, that's why. Minus to plus, minus 8 I3. Okay, and here minus 4 I3, this will be equal to 0. Clear or not? Now that is 12 I1 minus 12 I2, and that is 4 I2, and that is 12 I3, this will be equal to 0. 12 I1 minus 16 I2 minus 12 I3, this will be equal to 0. That is equation, or you can say divided by 4, that is 3 I1, 4 I2 minus 3 I3, this will be equal to 0, equation number 2. Okay, and here I2 minus I3, this will be equal to 4 milliampere. I2 minus I3, this will be equal to 4 milliampere. Now what about I1? I1, this 3 I1, this will be equal to 1 plus 2 I2, put here 1 plus 2 I2 minus 4 I2 minus 3 I3, this will be equal to 0. Okay, this value put here. Okay, then we got 1, this will be equal to, we got minus 2 I2 plus 3 I3, and this is also written as 4, this will be equal to I2 minus I3. Okay, now that is equation number 4, and here 5. Solving these two equations, that is 8 and this is 2 and that is 2 I3. Solving these two, minus, that is minus 7 and that is 0, and this is 5 I3. So I3 is minus 7 by 5. And what about I2? I2 is 4 plus minus 7 by 5. That is 13 by 5. I2. Apply KVL in this loop. Minus VTH plus 8 I3 minus 7 by 5 and plus 4 into 13 by 5, this will be equal to 0. So VTH is, what about VTH? VTH is 52 minus, we got minus 4 by 5. Okay, minus 4 by 5. So finally minus plus here RTH is 4.8 and VTH is 0.8. So VTH is written as 0.8 volt. Is a minus terminal, that's why. And RTS is 6 kilo ohm. Here X, here Y. Okay. So what about V naught? V naught is equal to minus 0.8 into 4.0 kilo ohm volt. 6 divided by 4.6 plus, then we got, solve this value with help of calculation. We got minus 0.444 volt is the final answer. Simply our motto determine V naught with help of Thevenin's equivalent, Thevenin's theorem. So how can we determine? First one, this one is converted like this one. Follows determine RTH like this one. All independent source reduced to be 0. Voltage source is short circuit and current source is open circuit. After that we got RTH. Now next target is VTH. Loop current I1, here I2 and here I3. Okay. After that apply KVL and we got I1 and I2, I3, and again apply KVL in this loop and we got VTH is 0.8. Thevenin equivalent corresponding to XY, that is making like this one, and load resistance here, and apply voltage divider rule and we got 0.44 volt.